list. Next heading, linked list. What is array list? Array representation of list implementation class. It is linked representation. Noted. It is a linked representation of list implementation class. Array list is an array representation of list implementation class, but it is a linked representation of list implementation class. It is a linked representation of list implementation class. See, in a linked representation, single linked list, double linked list, circular linked list, three concepts are there. But they implemented double linked lists. Note. It is an implementation of double linked list data structure. It is an implementation of double linked list data structure. It supports all the operations of double linked list data structure. It supports all the operations of double linked list data structure. So linked list nothing but it is a linked representation of list implementation class. It is an implementation of double linked list data structure. It supports all the operations of double linked list data structure. It allows duplicate elements because it allows duplicate elements because it implements list interface. It allows duplicate elements because it implements list interface. It occupies more memory because data stored in nodes. Here, each node has three parts. First one, left link field. Second one, data field. Third one, right link field. Here, each node has three parts. First one, left link field. Second one, data field. Third one, right link field. I'll explain, write it. Left link field contains previous node address. Data field contains data. And right link field contains next node address. So array list, linked list. Array list is array representation. Linked list is linked representation. What is linked representation? I would explain with the diagram. I'll explain with the diagram. So array list is array representation. Linked list is linked representation. Representation method is different. Okay. In data structures, we'll call it as double linked list in data structures. Duplicate elements are allowed because list interface. It will occupy more memory because data stored in nodes. Each node has 3 parts. Say node will be like this. It is node diagram. It is left link field. Data field. Right link field. Left link field. Data field. Right link field. It contains previous node address. Left link field, data field, right link field. Here, previous node address. Here, previous node address. Here, data. Here, next node address. This is node diagram. This is node diagram. This is node diagram. This type of nodes linked together, that is linked list. This type of nodes linked together, that is linked list. I'll show you with the diagrams. Is it over? Say every element, three parts. Every element, three parts. Left link field, data field, right link field. Data stored here. Here previous node address stored. Here next node address stored. That's what it will occupy more memory. It occupies more memory because data stored in nodes. One element, if you want to store, 3 slots required. 1, 2, 3. 10 elements, if you want to store, 10 into 3, 30 slots required. Okay. That's what it occupies more memory because data stored in nodes. Node contains 3 parts. See, linked representation. This type of nodes linked together with addresses. That's what linked representation. And list interface implemented. In data structures, we'll call it a double linked list. But class name is linked list only. But it is double linked list concept. In Java, single linked list, circular linked list not implemented. They prepared only double linked list. That class name is linked list. Okay. In data structure, we'll call it a double linked list. But in Java, we'll call it a linked list only. Whatever double linked list supported, those all operations supported. And duplicate elements allowed because list interface. More memory because for every element, 3 parts required. That's what more memory. Left link field contains previous node address. Data field contains data. Next node link. Next right link field contains next node address. Next. It does not require shuffling of data. It does not require shuffling of data. But how it is possible, I'll show you. Here, insertion order is preserved. Here, insertion order is preserved. It allows null values also. It supports both homogeneous. It supports both homogeneous elements and heterogeneous elements. It supports both homogeneous elements and heterogeneous elements. Here, initial capacity is 0. No elements. Initial capacity is 0. Initial capacity is there, load factor required. But initial capacity only 0. Then load factor not required. So these many points are there, you observe. This is all you have to remember. Interview purpose required. These all I'll explain. Is it completed? Now, see the program. You have seen array list. Like this array list object created. Like this you created array list object. Okay. Array list class in which package? Java.util package. So this is required. Now, in this line, how many elements memory located? How many? 10 elements memory located. Is it type safe or unsafe? Unsafe. Okay. If you want to write, if you want to maintain integers, you are right here. Is it homogeneous or heterogeneous? Homogeneous. Is it homogeneous or heterogeneous? Heterogeneous. Okay. Now, same style, linked list. LL equal to new linked list. Now, how many elements memory allocated? 0. No elements. Okay. Is it type safe or unsafe? Unsafe. Is it type safe or unsafe? Type safe. Is it homogeneous or heterogeneous? Homogeneous. If you want to write heterogeneous object, okay. Now I'll go for integers. Now LL dot add one element. LL dot add one element. LL dot add one element. LL dot add 1 comma 99. System dot out dot println LL. If it is array list, what is the output? 83, 99, 45, 81. Okay. Now also same output comes. Same output. See, file, save. Now also you'll get a same output. There is no difference. See. See, same output. There is no difference. Output. But internally, lot of difference is there. Okay. That difference I'll explain. First, you write this one. Write this program. Write the program. Now I'll show you with the diagrams. What is the difference? I'll show you with the diagrams. '99 inserted in one place. Index starts with 0 only because it is internally arrays only. Is it over? Now I'll explain with the diagrams. Array list, linked list. Both the programs output will get it same. Okay. But there is a lot of difference internally. Memory point of view, performance point of view, there is a lot of difference. What's the difference? I'm going to explain. First of all, you observe these many points are given. Now, it is a linked representation of list implementation class. But the array list is array representation of list implementation class. First representation method is different. Okay. This representation diagram I have to explain. It is a double linked list data structure. That is linear list data structure. Whatever linear list supported, that is array list supported. Whatever double linked list supported, that is this is supported. Okay. Here duplicate allowed. There also duplicate allowed. Here occupies more memory. There it occupies less memory. Here data stored in nodes. Every node 3 parts. Triple memory required. Okay. Here shuffling is not required. Without shuffling data inserted. But there shuffling compulsory while inserting while deleting. Insertion order preserved. There also preserved. Here null values allowed. There also allowed. Here homogeneous, heterogeneous. There also same. Here initial capacity is 0. There 10. Now, first you note down diagrams I'll give. Before that, difference I'll give. Differences between array list and linked list. Differences between array list and linked list. Note down. Differences between array list and linked list. Differences between array list and linked list. One side array list, one side linked list. One side array list. One more side linked list. Note down. Differences between array list and linked list. One side array list. One more side linked list. It is an array representation of list implementation class. It is a linked representation of list implementation class. It is an array representation of list implementation class. It is a linked representation of list implementation class. It is first difference. This is a diagram. With a diagram only you'll understand. With a diagram only you'll understand. Second difference. It is an implementation of linear list data structure. It is an implementation of double linked list data structure. This is also with a diagram only you'll understand. First point also, second point also, you can understand with the diagrams only. With the diagrams, I'll explain. It occupies less memory. It occupies more memory because data stored in nodes. It occupies less memory. It occupies more memory because data stored in nodes. Here, by default, initial capacity is 10. Here, by default, initial capacity is 0. Here, insertion and deletion operations require shuffling of data. Here, it does not require shuffling of data. Here, insertion and deletion operations require shuffling of data. Here, it does not require shuffling of data. Here, insertion and deletion operations require shuffling of data. Here, it does not require shuffling of data. Any other difference identified? See? Or no? Data shuffling with a diagram I'll explain. Now, next, actually, this first point, second point, all points with the diagram only you'll understand. All points with the diagrams on. With the diagram only, you'll get a clarity. Here, shuffling is not required. Without shuffling, only data inserted. Without shuffling, only data inserted in linked list. Now, array list diagram, linked list diagram I'll give. With that, you'll get a clarity. So, their duplicate allowed. Here, duplicate allowed. Their null value allowed. Here, null value allowed. Okay. Their homogeneous allowed. Here, homogeneous. Their heterogeneous. Here, heterogeneous. These are similar. Same. But these are differences. These 5 differences are there. Okay. Now, I'll show you with the diagrams. Or see. You observe. RL is integer AL equal to new RL is. AL dot add one element. AL dot add one more element. AL dot add 1 comma 99. System dot out dot println AL. If I write like this, in first line, how many elements memory allocated? 10 elements memory allocated. 10 elements memory allocated. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is one array list object. This is one array list object. Array list object. This object referred by AL. Okay, like this. Okay. AL dot add 13. 13, where it is added? 0 place. 13. 83, 1. Whenever you add 1 comma 99, what will happen? Is it modified? No. Data shuffled. Control shifted. 83 comes here. This 83 plus 99 stored here. Output will be output 13, 99, 83. This output comes. Okay. This is array list. This is yesterday only you studied. Linked list I'll explain. Try this one. Array list. This is array list diagram. This yesterday only studied. Same style. Is it over? Whenever first line is executed, 10 elements memory allocated in array list. Okay. That array list referred by AL. When second line executed, 13 added 0 place. When third line executed, it is added in 1 place. But whenever you add 1 comma 99, it is not modified. Data shuffled. It is shifted here. Whenever you print, like this printed. This is already you studied. Okay. Now linked list diagram I'm going to explain. Listen with more concentration. I'll give time for writing. First, you listen. Okay. Then you will understand the difference between array list and linked list. Is it over? See. See. If I write linked list, linked list LL equal to integer LL equal to new linked list. If I write like this, same code I'll write. LL dot add. What is the number I given? 13. Next 80, 83. Next 1 comma 99. System dot out dot println LL. You observe code is same. Code is same. Okay. Now what will be happen? Just you observe. When first line executed, what will be happen is like this created. First, last. First and last, some memory allocated. First and last. This is linked list object. This object referred by LL. This object referred by LL. Here null will be there. Here also null will be there. Okay. See. First, it is reference, which refers first node address. Present there is no node. That's what null. Last is reference. It refers last node address. There is no last node. There is no first node. That's what null. So when this first line is executed, whenever this first line is executed, memory allocated like this. Okay. In this linked list object, two references created, both the references contains null only. Okay. Because there is no node. When second line executed, first what will happen? This is as it is will be there. This is as it is. This is as it is. First, last. Like this, linked list object. Okay, otherwise, only that part I'll write outside. 1 minute. See. First, last. Here null. Here also null. Now you observe as it is I written outside. That's it. When LL dot add 13, then what will be happen is one node created. One node created here. 3 parts. One node created which contain 3 parts. It is left link field. It is data field. It is right link field. Left link field contains previous node address. This is only first node. There is no previous node. That's what here null will be stored. Data field. Data. Next node address. There is no next node. That is only last node. So null. Like this. Now what will happen? It is only first node. It is only last node. That's what this node address only placed here. Here also, this node address only placed here. So it is only first node, it is only last node. First place, first node address. Last place, last node address. Like this stored. Now what will happen? See, this is as it is, all right. This is as it is. This is as it is, all right. First, last. Okay, as it is. Here, this node address. Here, null. Here, 13. Here, null. That is created. Okay. When third line executed, one more node created. One more node created. Now, one more node created here. Separate node created. Now, here, what will be their previous node address? So, this node address stored here. Here, what will be their data? 83. Here, next node. There is no next node, null. But now it contains next node address. So it is modified with this address. Now it is first node. It is okay. But this is last node now. It is link broken, new link created. New link created. Like this. Whatever I given pink color, no, that is latest. This is old. Like this. Now, next what will happen? As it is first created. As it is. Now, first as it is. It is first. It is last. Here. As it is. This will points to this one. Vanished. I didn't save that one. One minute. See, I'll write once again. Whatever I explained, that is, I'll make it fast. This one, note down. Already up to second line, third line. Note down. Right up to here. Was null,
Recording in
but next
progress.
node is there. Address placed here. Now it is last node also changed. Now this is not a last node. This is last node. That's what it will points to this one. Now you observe without shuffling data inserted. How? Just you observe. Here, first, last. Here, two nodes. This is as it is, I am writing. As it is. Now, this is first node. This is last node. This address here. This address here. Now, null 13 83 null. Like this, memory allocated. Now, this is only as it is written. Whenever this line is executed 1 comma 99, then one node created. One node created. One node created. Now, LL dot add 1 comma 99. It is 0. Now it is 1. It is 2 required. Then what will be happen is these links are broken. New links are created. This address here. This address here. This address here. This address here. Now, now what will happen? See, here first node address will be there. Here first node address. It comes to first node. It will print 13. Here next node address will be there. It comes here. Printed 19. Next node address will be there. It comes here. 83 printed. Null is there. Stop it. Reverse also. Last. Directly it comes here. 83 printed. Previous node. It comes here. 99 printed. Previous node. It comes here. 13 printed. Null. Stop it. So, here between 13 and 83, 99 inserted. But data not shuffled. No? Without shuffling of data, element inserted. Suppose 1000 elements are there in array list. 0 place you'll insert. 1000 elements are shuffled. But here, no. Suppose 0 place if you want to insert. Another node created. This node address placed here. This node address placed here. This will points to this one. Over. This link is broken. Now, without shuffling of data, node can be inserted. Without shuffling of data. Then shuffling, what is the problem is burden to processor. Processor continuously it works while shuffling. That is burden to processor. So here suppose 1000 elements are there. First place you want to insert. The link broken, new link created, that's it. But elements are not shuffled. But their elements are shuffled. Shuffling means it is burden to processor. Continuously process will run. That burden to processor. But this one also one disadvantage is there. Memory. RAM purpose it is more memory. If you think about RAM, that is better. If you think about processor, this is better. Depends upon situation. Suppose in your application again and again insert delete is there. Shuffling this linked list is better. Suppose only adding at the end is there. Array list is better because your memory wasted. You take anything in the world, advantage will be there, disadvantage will be there. But according to our requirement, we have to select. According to our requirement, you have to select. You take anything in the world, there is a definitely advantage, there is a definitely disadvantage. According to advantage, you have to select. That's it. Okay. Now, if you think about memory, array list better. If you think about processor, linked list is better. Like that, depends upon requirement, we have to select. Write this diagram. Without shuffling of data, you can insert node. Anywhere you can insert. Starting also, ending also, in between also, anywhere. So that is less burden to processor, burden reduced to processor with this concept. If the application requires again and again insert delete, which one is better? Linked list is better. Only adding is there or else better. Like that you have to select. See, it is an implementation of double linked list data structure. For double linked list only, previous node, next node, two address will be there. Single linked list, only next will be there. Previous will not be there. Circular linked list, again last node linked with first node. That is circular. Okay. It is double linked list. Double linked list node only contains 3 parts. Single linked list contains 2 parts. Data and next node address. Okay. See, if this is points to this one, then circular. Okay. If only nodes are like this, here element, here next node, that is single linked list. But in Java, they prepared only double. Whatever required for application in real time, that is only prepared. Total data structures are not there in Java. You're right. Prepared data structure I'm explaining. But if you want to prepare, again that is 3-4 months course, that is Java with a data structure. That is separate course. Here, predefined data structure we are using. But if you want to create linked list your own, possible. Create one class node. In that, create node references. Like that we can create. It is possible. Is it over? Next, the hierarchy of list implementation classes. The hierarchy of list implementation classes. The hierarchy of list implementation classes. Now see the hierarchy of list implementation classes. Differences between array list and linked list, it's over. The hierarchy of list implementation classes. 2 list implementation classes, array list, linked list. See, at the top of the hierarchy, object class. From object class, abstract collection class derived. It is one class. Okay. Collection interface different, this class different, not same. From this, abstract list. From this, array list. Here, abstract sequential list. Here, linked list. Ready, son? Object, abstract collection, abstract list, array list, abstract sequential list, linked list. Or say, suppose you want to perform one operation on array list. You will search for method in array list. If the method is not available, then where you have to search? Abstract list. Here also not available. Abstract collection. Here also not available. Object. That purpose hierarchy. Okay. Here also not available. Then not possible. Okay. Now, using array list object, can I call abstract sequential list method? Can I call? No, you cannot call. It is not no relation between these two. Using linked list object, can I call? Yes. Using linked list object, can I call array list? No. Here, what they did is, which are common to these all, they placed here. Okay. Again, which are common to other collections, they placed here. Which are common to total Java library, they placed here. Like that. Now, object class methods, any class can access. Because object is the top of the hierarchy. Okay. In the collections also, all one-dimensional collection from this class only. All list from this one only. Like that, list purpose one separate class. Map purpose separate class. And set purpose separate class. But again, all classes derived from abstract collection. Again, with total Java object class. Like that, they placed it. Okay, reusable. Otherwise, here also you have to write, here also you have to write. Instead of writing here and here, they placed it here. Which are common to both the array list and linked list, they placed it here. Which are common to all collection, they placed it here. Which are common to all Java classes, object. Like that, they placed it. Okay. You already studied Java.util package classes and interfaces. How many categories divided? How many? 2 categories. What are those? Collections, framework, collections, legacy collections. Collections, framework, collections means JDK 1.2 and above versions. Legacy collections means 1.0 and 1.1. Those class and interface legacy collection. Collections, framework, collections. How many subcategories divided? 3. What are those? Core collection interfaces, general purpose implementations, more utility collections. Core collection interface, how many are there? 10. The 10 theory part completed. General purpose implementation, how many? 10. How many completed? Only 2 completed. Next, third one. Has set. Next one, has set. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. Here, array representation, it's just like an array list. Representation, array type appears. But one data structure implemented hashing. Every day we are calling hash code, hash code, hash code. That is you'll learn today. Okay. There are 3 techniques in data structures: sorting, searching, hashing. Sorting, searching, hashing. What is sorting? Sorting means arranging data in ascending order, descending order, alphabetical order. This all comes under sorting. Now, what is searching? You can find element location. Searching for element location. What is hashing? Sorting also you give an answer. Searching also you give an answer. What is hashing? What is it? Encoding. Encoding, decoding. No, that is not compulsory. Finding. Finding element location is searching. It is also like that only almost. But little bit difference is there. See, hashing also, it is similar to searching only. But as compared to searching, very quickly searching possible here. Very quickly. See, searching techniques, two techniques are there in data structures. Sequential search, binary search. Sequential search, binary search. Sequential search, how it will search? So, like this, elements are there, suppose. Suppose 1000 elements are there. Assume 1000 elements are there. Then 1000 elements, index starts with 0. Then ends with 999. 1000 elements means. Okay. Year, element 45, 81, 13. Now, if you are searching with a sequential search for 45, how many iterations comes? Sequential search, how it will search? First it will search here, not there, next, not there, next, not there, next. Like this only it will search, no? It is called sequential search. Suppose you are searching for 45, how many iterations? If you are searching for 81, you are searching for 13, you are searching for 82. 1000. It is index. Okay, it is index. If you are searching for 45, 1. If you are searching for 82, see, if the element is starting with very quickly comes, the element is ending, it takes more time. Okay. Binary search, how it will search? Divided by 2. First, all elements should be sorted. All elements should be sorted. 1000 by 2, 500. Exact 500 place it will search. That element not found. Less than left side. Greater than right side. Again, 500 by 2, 250. Then 250 place. Less than left side. Greater than right side. Like that, even 1000 elements also, element very quickly can search. Almost 10-20 iterations only will get it. The element can be anywhere. Element exact middle, 1 iteration. Exact element that corner or this corner, it takes time. But here also some gap is there. But hashing, element can be first also, last also, middle also, anywhere. Almost same time it will take. Very quickly comes. That is hashing. How? For example, you are using dictionary. In dictionary, 1000-page book is there. Suppose 1000-page book. You are searching for one word meaning. Are you searching first page, second page like that? That is called sequential search. Are you searching divide by 2 by 2? Dictionary 500 pages, 200 pages like that? No. That is called binary search. But you are searching for technique you are using, no? Directly go to, suppose hashing meaning only 1. What will do? Directly H. Next, HA. Next. Now, in the total dictionary, the word can be in first page, word can be in last page, word can be in the middle, anywhere. Almost same time it will take, no? That is called hashing. That is called hashing. Now, even 1 lakh elements also, 1 crore elements also, very quickly searching possible. That is hashing. That is the reason objects also maintained in a RAM with hash code. Very quickly process. The total RAM, 64 GB RAM also, 128 GB RAM also, where your object stored, very quickly it will retrieve, it will print. Because of hashing. Like even mobile numbers, telephone directories, they are maintaining with hashing only. Google search, they are using hashing only. In Facebook, they are searching for friend. LinkedIn, these all hashing techniques only. Everywhere hashing is there. Okay. Now, what exactly hashing not do? Hashing. Not done. Hashing is a technique in which insertion, deletion, and find hashing is a technique in which insertion, deletion, and find operations are done in a constant average time. Hashing is a technique in which insertion, deletion, and find operations are done in a constant average time. Inserting element also very quickly, deleting element also very quickly, finding also very quickly. So not only find, 3 operations done very quickly, constant average time. That means almost the same time for any element. That is hashing. Okay. It is just introduction started. We'll see continuation on Monday. Tomorrow I'm not coming. Tomorrow no class. We'll see continuation on Monday. Okay. Tomorrow no class. We'll see continuation on Monday.